we have David Stevenson, who's a coworker of mine at Pivotal Labs, and he's going to be talking to you about how to let users run untrusted code in a sandbox.
Thanks, Josh. Hi, everybody. I'm David Stevenson. I'm an employee at Pivotal Labs, and I do lots of Agile, web development, Rails, Ruby. I want to talk to you guys about the Sandbox today. There's a couple of things we should say before we get started, because Sandbox is a pretty experimental idea. I would ask how many of you have ever used the Sandbox, but it's probably a very small number of people here, if any, and it's not necessarily trusted to be production-level code yet. It's sort of an experimental idea. But we're going to, during this talk, we're going to get a chance to interact with it. I'm going to build some code. You guys are going to be able to interact with it in the audience, so if you have your laptops open, at some point there's going to be a few URLs that pop up. You can go there and start playing with the Sandbox, and there's going to be a competition to see who can compromise the Sandbox first. There's a cupcake involved. I haven't bought the cupcake because I'm optimistic that no one's going to be able to break out. And the rules are you can't use Rails or Ruby vulnerabilities to break out. You've got to break out of the Sandbox itself. I'm sure you can compromise my Linux machine or whatnot, but I'm not really interested in that. I'm interested in, is the Sandbox safe? And I think all of you are probably also interested in that as well. So, first of all, why would you even want to run user code in your application at all? I think that the biggest reason is that code is the most customizable way to allow users to change your application. It's more powerful than any user interface that you could come up with. You could make this really fancy UI where, let's say you're writing something that sits in a mail server, and basically you want to make a decision when a message comes in about what folder to put it in. Well, you could write this really complicated set of rules like Microsoft Outlook has, and you could kind of come up with a way that, a user could specify what folder it goes into. Or you could simply allow code to come into your application. The code can do whatever it wants and eventually make a decision about what folder to put it into, which kind of allows you to put these really complex business rules into your applications. And so my main point is that it's really customizable. Also, you get a little bit of benefit in that your users are writing code, they're putting it into your application, they're kind of helping you maybe build your application, depending on how it's designed. If you've read Neil Stevenson's book with the metaverse, basically people are constantly contributing code, and it's all running, and it's talking to each other, and it's talking to people. I imagine that could be a really enticing part of the Sandbox if you put it in your application. Certainly it's easier to write Ruby code than it is to write C code. I think we all agree there. And Second Life has used C, this sort of C language, to allow users to upload code. Well, if they can do that, then we can do this in Ruby, because Ruby's got to be a lot easier to write than C. It looks like English. You can have these domain-specific languages. So Ruby is a great language to allow Sandbox code in. It leads to some interesting gaming ideas. I already mentioned Second Life. How many of you have played Second Life, or how many of you have opened Second Life before? Okay, a quarter of you. Second Life is built on the premise that users want to create three-dimensional objects, and they want to attach code to them. And then the sky's the limit. The objects can interact with each other. They can interact with other users. Users can have objects on them, and it's crazy. But a lot of it's based on the premise of having a sandbox where users can put code in and have it interact safely with the environment. Finally, you could build a platform upon which users can upload entire applications, which are code, like Google's App Engine. And maybe you take some really hard part out, you're going to say, well, I'll build the scalability. You just give me your code and I'll make it scale. Well, you probably want to run that in a sandbox of some sort, because you don't want users to be able to get in under the covers. And there's a variety of techniques for this. So why wouldn't you want user-uploaded code in your application? I think that I don't have to convince you that this is pretty risky. Users could maybe do something really dangerous. Maybe they can access the file system, or maybe they can access the network, and then they start going nuts. They could have code that has errors in it, and maybe their code is really important to you. You've built a whole application around the idea that users can upload code, and then they upload code and it doesn't work. Well, you have to deal with that case. So the code could have errors. And of course, the code could not finish. Some malicious person's going to upload an infinite loop almost immediately. And if your application server is sitting in an infinite loop, you're in some serious trouble. Finally, there's social questions like, are your users programmers at all? Maybe 99% of my users don't know how to program, and they will never learn, not even 5 lines of Ruby to write, something that looks like English. So that's worth taking into consideration. And finally, you're going to provide an API to your users through code. Well, maybe that API can be manipulated in a way you don't understand. This is true with any API. I mean, the Facebook API could be manipulated potentially to do something dangerous. Hopefully the programmers spend a lot of time going through it, making sure that it can't be, there's no unexpected side effects. But because you're using code, I feel that that's a bigger concern, perhaps. Maybe there are ways of manipulating your provided API that you haven't even thought of yet. So, let's say you've decided that you want to allow user-uploaded code in your application, and you want to do it in Ruby. What's a sandbox? Well, Sandbox is going to provide some limited functionality. You can't just do anything you want in a sandbox. Hypothetically, you shouldn't be able to break out of the sandbox and suddenly run in the unlimited context. There's some code separation going on between the sandbox and let's call it the jungle. It's really important that if somebody changes the definition of something inside the sandbox, Ruby's an open language, so if I redefine a class in the sandbox that's really important, like string, to do something crazy, that doesn't affect the rest of my application. So there's got to be 2 separate code spaces, one in the trusted context and one untrusted. And finally, a good sandbox should probably cut off code that runs too long. I mean, we can't guarantee your code is going to finish, but we can at least stop you if you go too long. So there's some implementations in Ruby of this. There's 2 that are interesting. One is the most common, and it's using the JRuby MRI that we're all pretty familiar with. It's called the Freaky Freaky Sandbox, and it's written by Y the Lucky Stiff. There's a very small amount of code to it. And it's pretty much a hack. And I think Y will tell you that it's a complete hack. He's redefining a bunch of system calls in C, a bunch of Ruby methods in the C API, and he's basically creating a whole separate class table for within the sandbox and without the sandbox. And then he has to change all these methods so that they look up in the right class table, depending on whether you're in a trusted or non-trusted context. So it's a little bit of a disaster when it comes to the hackiness of it. I've played around with it a lot, and I feel like it works pretty well. You're going to get a chance to play around with it in a second, so I think you can tell me how well it works. The second implementation is for JRuby, and it's written by Olabini, and it's called Java Sand. He chose to use the same API as the Freaky Freaky Sandbox, which is really great in case you've written an application. You can port it over to the JRuby one. It's the same API. It's not as much of a hack. I think that JRuby provides some hooks into the internals, whereby you can actually do some of the stuff that the Freaky Freaky Sandbox does kind of, legally, instead of just by changing crazy functions. So I've tested both these out. They're not incredibly easy to install. Like the Freaky Freaky Sandbox claims to be a gem, but you can't install it using gem install, for example. So it's a gem in that you have to download some code and run ruby setup.rb. So I guess it's not a gem. And you also need to patch your Ruby interpreter to run these things, which everyone always says, oh. But you can only run it in Ruby 1.8.6 and 1.8.5. There's no support for the newest 1.8.7 or 1.9 yet. I think it wouldn't be hard, but Y has sort of stopped maintaining it. So that's another reason to go with the JRuby implementation, assuming you decide to actually try this out. I don't know a huge amount about Rubinius, but I do know that Rubinius has some features, including sub-VMs, which might make sandboxing really easy. Like maybe somebody could write a sandbox in 20 lines of code in Rubinius. In comparison, the C sandbox is about 2,000 lines. It's mostly C, and as we've discussed, it's a little bit tricky. So I'd be interested, after the talk, somebody who knows Rubinius really well could tell me what a sub-VM exactly adds to this. in terms of security and like separate classes. I know there's a separate heap involved, but it might work really well for sandboxing. So I thought we would try it out. I'll show you, it only takes about 4 or 5 minutes to build an entire application with the sandbox. So we're going to build a quick application. The goal is to basically just evaluate expressions. Like if you give me the expression 2 plus 2 into my application, I should return to you 4. If you give me math sine of 0, I'll give you 0. If you try to raise an exception, I'll maybe give you some information about the exception. And if you take too long, I'm going to cut you off with a timeout. So those are the 4 basic rules that we're going to try to evaluate. So I'm creating this thing from scratch. Hopefully we don't run out of bandwidth. But I'm going to create a Rails application. I know we just talked about Sinatra. What I like about Rails here, just for this project, is I'm going to use some scaffolding. And I don't know how to get something scaffolded that has like models, controllers, and views kind of in the time frame required to give a talk. But maybe that's possible too. So to use this C-based sandbox, I can just require it. I'm going to require sandbox. As soon as it's required, it makes a copy of the state of the world as it knows it when it loads. So like it's like, okay, object, I'm going to make a copy of that. String, I'm going to make a copy of that. File, kernel, some of these other dangerous things, it doesn't make a copy of. They're not accessible inside the sandbox. And we'll talk a little bit later about how you might want to expose those things safely to your users. So I'm going to generate exactly what we just talked about, a expression object. An expression has a string. That's pretty much it. Now I'm going to edit the unit test for it. And let's see, expression test and app models expression. And we're just going to write like 2 or 3 basic tests. And I don't know, let's do a little red-green output because that'll look awesome. I'm used to RSpec these days, and I've switched back to test unit. It's been very upsetting. And I've switched to VI for the purposes of this demo, which makes me also really sad. I'm used to using RubyMine, which is an awesome IDE. So let's write a simple test. 2 plus 2 equals 4. And our test should be, well, okay, let's create basically assert equal 4, and we'll instantiate an expression object, expr.new, and the expression we're going to pass in is 2 plus 2. 2 plus 2. And I'm going to call the value method on it. We haven't written this value method, but so let's go write it. I'm also going to delete the functional tests provided by here because there's too much noise if I don't. So 2 plus 2 equals 4 doesn't work because there's no method value. Just discussed that. Let's pop over to expression class. Now it's where it gets interesting. It's time to create a sandbox. The class to create a sandbox is called Sandbox. The method safe is a constructor that constructs a sandbox with all the dangerous stuff that I just discussed removed. You can also do sandbox.new, which will instantiate a full sandbox with everything. That might come in handy later. Somebody might come up with a reason to use that. I think most people want to run untrusted code, not trusted code, but there could be cases for running trusted code. So I'm going to evaluate the expression out of the database that you passed in, and let's try the test again. Great. Okay, 2 plus 2 equals 4. Now let's try something more complicated. Let's try raising an exception. I don't know, raising an exception. What should that do? I don't know, prints error. Instead of, okay, so, I don't know, how about we'll instantiate an expression, we'll have that expression raise the string, oops, and we'll check that its value includes the string, I don't know, runtime error, because that was sort of the exception that we're going to throw. If I run this right now, crazy stuff happens. Really, really weird error message happens. It says it can't find require for main object. There's some stuff going on in the sandbox. It's failing kind of in an ugly way. It's not really a big deal because you're never going to not want to catch exceptions. So you can just catch pretty much anything that comes out of the sandbox. I mean, if anything bad happens, like somebody raises an exception or somebody, I don't know, has a syntax error, we're probably going to just want to rescue every exception that comes out of this thing. And we'll have it return the, I don't know, inspect value for the exception. That way we get a nice error message like runtime error, oops, or something like that. Let's run that test again. Okay, good. We've got both tests passing. So I'm going to write one more just to show that there's an infinite loop issue here. I don't know, so infinite loop, we'll test that an infinite loop doesn't run forever. I'm going to do something very similar to the last test. Our expression will be, I don't know, while true. Seems like as good a loop as any. We'll check that the value includes some sort of timeout error. I'm not going to be really specific about what I'm looking for here, but it'd be nice if it was a string that said, hey, there was a timeout. Let's try running this guy again. As maybe some of you have figured out, this is never going to pass or fail, which is really unfortunate. Problem with test driving an infinite loop. So I'm going to just Control-C it. Sandbox eval options are as follows, like timeout as one of the supported options. So I can say, hey, how about after 2 seconds? Or how about after 1 second? We'll just cut you off. And 1 second. Great. So we got a small Rails app here. We're instantiating a sandbox. We're taking the expression provided by the outside user. We're evaluating it with a timeout. We're catching any exceptions, and we're returning them as a string. This is now done in that I'm going to expose it to you guys, the outside world. In order to do that, there's like 2 things. You know, Rails is being a little difficult here. I've got to set up like a route for it so you can actually get to it. But in about 30 seconds, I'll pull it up in the web browser, and I'd be really curious, maybe even by the end of this talk, what people have uploaded. And if any of those maybe access certain things on my file system, it would be nice to know. Okay, we've set up the last thing is there's no way to actually see the result, because when I generated the scaffold, it didn't come, there's only one part here, right? There's the expression, but there's not the value. So let's just paste in the value. Otherwise, it would be kind of pointless. Dot value. I'm going to run inspect here too, so you can see like if it's a, I don't know, might provide a little more information. Great. So the application's ready. I'm going to go ahead and start it up. My 502 bad gateway has changed to, so that's the URL. We'll put it up in, actually it'd be kind of neat if Josh could Twitter a few URLs from this, because I'm going to leave these things up throughout the course of the conference, and I'm really interested in what's up there when I'm done. I'm going to write a simple test expression. 5 plus 5, 10. Great. So I'm going to turn that part over to you now and continue talking a little bit about how to build something that actually maybe is a little bit more interesting than just an expression parser. So if you didn't get that URL, you're going to get a chance to see it again in a second. How does this whole sandbox thing even work? I've kind of alluded a little bit to this before. There's kind of this idea, as you can see up here. This tan box represents what's defined inside the sandbox, and then everything else is outside the sandbox. You can see that inside the sandbox, there's like an object class, and there's a fixed number class, there's a string class. There's some really basic stuff that you couldn't write any useful Ruby code without having those classes. It's a different object class and a different string class than you might find outside the sandbox. So maybe I've removed some dangerous methods. Like it doesn't have to be the same object and string. Now, when I pass a string into the sandbox, or maybe I get a string out of the sandbox, or a fixed num, any sort of object that's going back and forth between the sandbox and the jungle, it gets converted into a marshaled binary state and then gets unmarshaled inside the sandbox. So this kind of allows us to have a string outside, which has different methods, serialize it, deserialize it in the sandbox, and now it has maybe reduced functionality. So there's marshalling going on. Marshalling isn't always good enough. Sometimes you actually want to do something dangerous inside the sandbox, but you want to control it. You don't want to just like open up net HTTP and say, oh, because I'm building some sort of web crawler thing, and you guys can tell me like what to crawl, and then I'll give you, I'll push into the sandbox maybe the contents of the page, and you can decide what to do with it. That's a great idea, but I don't want to expose net HTTP to you because that's a disaster. You're going to start doing all sorts of random bot stuff. So I might provide a method like, in the crawling case, I might provide a method like get. Maybe you pass me a URL. So I'm assuming that you guys are the uploaded code and I'm the application. So I'm going to provide a method where you say, hey, get me this URL. I'll go get the contents of it outside the sandbox where I can do whatever I want. Maybe convert it to a string and then pass it back to you. Then you can do whatever you want to it. You can parse it, run regular expressions on it. So the only problem with that is that this method called get that I just talked about has to do something that's pretty dangerous. It has to use net HTTP. There is no net HTTP in the sandbox. We got nothing. We got no file. We got no kernel. So I've got to have a way to deal with that problem. And the sandbox provides a way to reference a class. So most classes, as you saw in the beginning, are copied in. Object was copied into the sandbox when it first started up. String was copied. I can reference a class, like my API class here, this example. Maybe it's got some unsafe method, some IO method that does some things that I wouldn't want you to be able to do by yourself. So by referencing it into the sandbox, another copy is defined with just a method missing. When that method missing is called, it unboxes the sandbox, runs the contents of the code outside of the sandbox where it can do whatever it wants, takes the return value, marshals it, and re-enables the sandbox. This is pretty powerful. It allows you to provide an API that actually can do unsafe things, but the people inside the sandbox cannot run those unsafe things by themselves. They have to run it through your method. So that's how we get around these potential problems. I've written 2 support gems to kind of help people. After writing a few sandbox applications myself, I realized that one thing I wanted to do was I had this really sweet API class, but it often had a bunch of methods I didn't want you to be able to use inside the sandbox, so I kind of wanted to use a proxy pattern and say, well, maybe you can call this method because it's safe, but you can't call this other method because it's unsafe. Access wrap class is a gem, gives you some of this support easily. You can kind of see from the example here at the bottom, I've defined 3 methods. One of them is a bad method, and I don't want you to be able to call it in the sandbox. So I say access wrap class. This just similar to Nick Kalin's proxy pattern talk. It's just using a proxy pattern here. It's creating another class called like my sweet API wrapper, which basically just has a method missing, checks a list of methods that are allowed, and dispatches the call to the real class if it's allowed. I can then combine this with a sandbox, and I've written another gem called Access Runnable Code, which kind of does some of this marshalling for you. It's more designed to set up the sandbox easily for you, but it also deals with the fact that you want to wrap up these classes so that they are protected and you can only call the methods you want when you pass them into the sandbox, and you want to unwrap them when they're outside the sandbox. So there's some boxing and unboxing going on here. Access Runnable Code is the glue that brings all that together. You might have like a model, say in Rails, called algorithm or your algorithm, and it extends from active record base, and it contains the code. Maybe this is the code you uploaded. I can call Access Runnable Code, give it some options, and Access Runnable Code allows me to say, okay, I want to run that code in the context of my sweet API.new. So I can pass in an object, and that code is run in the context of that top-level binding. This has a lot of sweet applications. I'm going to show you next an application that uses both of these gems, which you can also play with, and it's a game. The game is Hangman. I think probably most people know the rules, but the idea is you get a certain number of guesses. You're trying to guess what the word is that was chosen randomly by the system. So let's say the word is hello. I provide some methods, and one of those methods is to actually make a guess. So you can decide what letter you want to guess next. You can see all your past guesses. you can see what the word looks like, except you can't see the parts that aren't filled in. So there's a space where the E is in hello because you haven't guessed E yet. And finally, I let you have access to the entire dictionary. This is great if you want to do some sort of crazy regular expression thing where you figure out, based on the word, what's the most likely letter I should guess next. So I give you complete access to the dictionary that I'm using to choose the word. This is up right now, and there are a few more rules. You only get a certain number of wrong guesses before you're disqualified. All of the algorithms are sort of running at once, right? So right now, it's running in a cron job. The word is nation. It's run 3 iterations right now, and I've entered my algorithm only, which is called sequential. It guesses sequentially all the letters one at a time. It pretty much gets all of the words wrong. Every once in a while it will get 1, because you can make the word damage with only the first few letters in the English alphabet. I'm hoping to see some better implementations. You can click New Algorithm on this and actually start writing code. You can say, oh, I want to guess A all the time. That's a pretty bad algorithm. And you can password protect this algorithm, so only you can edit it. I'd be curious. And about once a minute, an iteration will run. All the algorithms will be asked to submit a guess. If you try to guess twice, I disqualify you. If you don't guess, I disqualify you. And you have a certain number of wrong guesses until you're out, and then you'll have to wait till next iteration, and then another word is chosen. So, also you should know that if you submit an algorithm, it doesn't get entered until the next word starts. You can't start halfway through. Your algorithm will be entered next time. So I'd be really interested in what people submit by the end of this conference. Let's take a look for one more second back here at these expressions. I'd be interested. Interesting. How did that backtick RMRF work out? Turns out Rails is really bad at generating these. Compile error. Interesting. So there's a syntax error in this. What's going on? Oh, sorry. Yeah. What's up with that? LS. Great. So there's no backtick method defined in the sandbox. So too bad. What else? Sleep 1. That's fine. Undefined method sleep. There's no sleep in the sandbox. Why are you sleeping? It's a sandbox. Context.freeze. I haven't tried this one. That one's deleted. While true, end. Timeout. So, great. There's a few sudo reboot. Great. I'm not going to show all these, but you can get on this site right now and see if any of these break. Raise your hand if you think you broke out. Okay. That's a start. I'm about out of time, but come up and ask me if you have any questions later. I love this sandbox stuff. I didn't write it. I know a lot about it, though. I'm happy to help you figure that out. Thanks.